Welcome to Programming in Modern C++. We are in week 4 and we are going to discuss module 18. In the last module, we talked about the notion of friend function and friend classes. Particularly, if I would talk about the previous one also where we covered about static. So, with the static and friend function, we have extended the capabilities of the classes to a significant extent. And in the current module, we will talk about overloading of operators for user defined types. This is not the first time you are hearing about it. We have already talked about this in at least 2 modules earlier, in module 9 and module 14 as far as I remember. And but here we are going to develop the operator overloading concept in a very structured and comprehensive way and continue that in the next module too. Outline, as you know, will be available on your left. So, I start with a quick recap of things we have already discussed. If you have further doubts on them, you can go back to the respective modules and look up the details. So, you have seen how to overload a operator plus, let us say, for allowing the concatenation of strings as a addition operation. We have also seen overloading, this was done in module 9. We have also seen the overloading of assignment operator, copy assignment operator as we said in module 14, which can define different kinds of deep or shallow copy semantics for this assignment operator. But in general, so these are 2 specific examples we did. In general, what do we want to do? One of the main reasons of operator overloading is we want to build up algebra of our types in the very same way as is available for the built-in type. So, like we have int type, we can write a complete algebra for that, a plus b into c dash, all of those operators and so on. We can do that for double. But if I want to define a complex type, now I know how to define that type in terms of having private data members, double, real, double, imaginary and constructor, destructor, all that. But how do I build a complete complex type with addition, subtraction, multiplication, conjugation and comparison, all of that, so that I can just the kind of expressions I can write with int, I will be able to write with complex as well. Can I do that for proper fractional type, rational numbers? Can I do that kind of? Can I have similar types built up for matrices, for sets? So far we have been reading or writing values using separate member functions. Can I extend the streaming operators for any of these types that I am defining and directly stream a complex object to the cout or a rational object to the cout and so on. Further, these will not come as a part of this module, because each one of these is by themselves very deep. One is, can I have smart pointers? Can I have operator overloading for the pointer operations, which is dereferencing and indirection and copy and compare and so on. And there are several reasons of why I want to do that. I would like to have smart pointers. They refer to other objects by address, but behave in the way I want, not their default behavior. Right? So, that is smart pointer. So, we will have a separate discussion on that. And very interestingly, we will talk about function objects or functors. These are objects or these are classes where the function call operator itself is overloaded. So, we know that functions are as defined and you can use the name of the function and call it. Have you ever heard of that you can have a class so that its instance could be used to call a function? The instance itself will be calling the function, not a member function, but that itself. So, there are several effects of that which lead to function objects or functors, which are very, very critical, and particularly with an eye of going towards the modern C++ part, the C++ 11 part, where you have lambda functions and so on. We need to have a good understanding of the functors, and operator overloading is the critical mechanism for all of these. But the present module and the next will focus on this part of requirements of operator overloading. These two will come later on in separate modules. So, with that quick recap, just to tell you that every operator can be thought to be associated with a function using the keyword operator. So, this is what happens: a plus b is operator a b, a assign b is operator assignment a b, and so on. So, this is in C++, you can think of these as these kind of operators. Right. Now, there could be several non-member operator functions. That is, a operator function could be a global function or it could be a friend function. Right. They are not necessarily a part of the class. So, if I have a certain type A and B, enumerator, enum type, struct or class, then I can have a class operator plus, which takes two parameters by reference of my type and gives me the result of the addition as a return type. I can also make that a friend function of a class. Right? Each one of this is possible. This is for the binary operator. I could have for unary operator also. Unary operator, as you know, could be a prefix operator or it could be a postfix operator. So, if I have a prefix operator, then this is what I am showing will be applicable. We will talk about the postfix operator as a special case later on. So, this is a global function and this is a friend function, and here are examples of the same. You can see that this is a postfix operator, postfix unary operator. So, here in addition to the actual operand, you just have a dummy int just to differentiate these two. Whether it is prefix or postfix, we will have examples of that. So, this is the typical non-member operator functions. There could be member operator functions also, that is, the operator could be a part of a class. Right? If it is a part of the class, then certainly it takes only one operand in case of a binary operator. Why? Because the being a member function of the class, it is always invoked on an object, and when it is invoked on an object, that object is by default the left operand and the other right operand needs to be passed. So, you see only one operand, but actually there will be two inside. Similarly, for a unary operator, you will not have any operand because it is invoked on the object. So, that object itself is the operand. If it is pre-increment kind of, you write like this. If it is a post increment, then you need to have that dummy int type to designate it. So, now you see the equivalent expressions between the infix and with the operator these are not global, right. Just to point it out to you. See, this was about the global, right. So, you can see all of them were having two or one operands, and these are global calls, not with respect to any particular object. But when you have that, as in here, I am saying that this is my operator defined in this class, then I have the left operand coming as the object on which the operator is invoked, and the right operand being taken as an actual argument. Right? You can see the effect of this also. So, what is this? This part will happen first. So, it is A dot operator plus B, and that result will be assigned to C. So, C is the left hand operand. So, C dot operator assignment of this value. So, these are the equivalent function like notation which will actually get evaluated internally. So, operator overloading rules we have discussed. You cannot define a new operator, you cannot change the arity, precedence or associativity of any operator, and here there is a list of operators that are available for overloading, quite a few of them. Some operators like scope resolution, class membership, member access through pointer, size of question mark colon, the ternary operator cannot be overloaded. Some has a difference in behavior if you overload in terms of shortcutting or shortcut evaluation or sequencing not working for them, and so on and so forth. We have discussed this. I have included here just for completeness. If you have doubts, go back to module 9 and listen to that part of the discussion. Now, let us see how do we overload operators using global function. So, here two examples. On left we are trying to overload for adding two complex number, on right we are trying to overload for concatenating two strings. So, for simplicity I am using struct here, because struct, as you know, is a class in C++ with where everything is public. So, it has two data members which are necessarily public. I define a global function operator plus, it is a global function not defined within struct, which takes two complex numbers, does the addition into a local temporary complex number and returns that. The return has to be by value, because for two reasons. One is that local objects cannot be should never be returned as a reference. More importantly, it has to be a value because it is something new that is happening. A and B existed, but the result, the R, did not exist. So, it will have to be a new object. So, with that you can write the addition of complex exactly in the same way as you write the addition of two integers, and you will get that. Similar thing I can do for a string type, where the typical C string a character pointer is wrapped. In the operator plus the global function overloading the concatenation, I do the standard concatenation code. So, that now I can easily write a fname plus lname, where these two are two strings, to actually concatenate them and get the result. So, that is what I was meaning, that these are the ways to kind of write them as an algebraic form than doing several function calls. We have seen these examples in a certain way before, and we have seen kind of what are the limitations of this semantics and so on. What I want to point out is, certainly here it is a global function, and naturally it has to use public data members. It is using public data members, and the moment we do that, no encapsulation, it is unsafe. So, you know how to take care of this. Say for the case of complex numbers, I can easily take care of this by making these data members private. I call it class now, make this private and provide the get set functions on the members as an interface. So, this is a standard information hiding paradigm we have done, and then define this operator plus as a global function, right. So, as a global function it has to use these get set functions to actually be able to define the operator plus, right. Good enough. The problem is it really gets clumsy if your operator function code is long, it really gets clumsy with this get set functions and so on. So, you can work out of that. So, what is the problem that you are getting into? You have a function, global function, which is an operator function. It needs to use the internal state of the object to be able to define that operator function, and being a global function it cannot do that. If you put the variables, put those data members in public, you have information leakage, it is not safe. If you put them into private, then you can follow the information hiding paradigm, but you have the difficulty that you have to do I mean you can see how cluttered this code is becoming with real, img, this, that, lot of get set calls. So, if we instead of using global function, if we use member functions, then certainly we can do easier things than this. So, let me do that same thing, the private data members, but I have moved the overloaded operator plus inside the class. As I move it inside the class, I need only the right parameter. The left parameter is the object on which this is getting called, because when I write it like this, it means C1 plus C2 means C1 dot operator plus C2, right. This is what it actually means, right. Since it means this, so this is where C2 will come, and C1 is the left hand side operand, which is the object on which the call is being made. So, these are components of C1, the current object. If you want to be if you want to make it very explicit, you can write them as this pointer RE, and these are components from the right hand side. There is no issue of accessing these components because it is a member function now. So, with this the basic problem of safety and also the clumsiness that we got in terms of using the global function is removed. I can very easily write this and write all sorts of operators for complex and have a very nice complex data type created in parallel to the built-in types. Similarly, we have we studied about the assignment operator. This is the overloading of the assignment operator. We studied that self copy needs to be guarded. So, if it is an assignment to itself, then you do not do it, do nothing, and this is what ensures that you do a deep copy. That is, if you the pointer, you do a deep copy. So, when you do this assignment, the assignment like this, then you will have the function called as S1 dot operator assignment like this. We have seen all of these, and we also noted that there is a difference between deep copy and shallow copy, and if it is operator assignment, if it is not overloaded by the user, the compiler provides a free one which does a shallow copy. Right? Please remember that if the operator constructor uses operator new, then operator assignment should be overloaded. You must provide your version. Similarly, if the copy constructor you need to define a copy constructor, operator assignment must be overloaded and vice versa. Basic rules we have already seen. Let us move on to overloading the unary operators. So, I have a my class which has only one int data member. So, it is kind of a wrapper of an integer, right, which is private. I want to define pre-increment and post-increment operators for that. So, for pre-increment operator I have no argument because I am working on the object only, and for the post argument, just to make it syntactically distinguishable from the pre-argument, I have a dummy int parameter for which I will actually not pass any parameter, right, and it is acceptable. Now, this is pre-increment. So, it will first do the increment and return me the incremented value. So, as it does the increment, what should it return? The incremented value, that is the incremented object itself. So, I have to return start this much in the way we did in case of operator assignment. What if I do a post increment? What do I want? I want the current object to change, be incremented, but the object returned must be the old object. So, I have to remember the old object. This is where I remember the old object. I will need a copy constructor for that. So, that t becomes my old object. Then I increment data. So, my current object is incremented, right, and then I return that object. Right. Here I am not returning the object itself because object itself has changed, but you want that change to take effect separately and you want the original value back. Right. So, if we do this in case of here and here, the post increment and pre increment, you will see the effects taking place. That is straightforward, that is nothing, no specific fun in that. You could have done it with int, but what we want to really learn is how to write this pre increment and post increment operators. Now, while we call them as pre increment post increment operator, it is not necessary that when you overload you will have to do increment only, you can do something else. For example, here I have a pre operator plus plus where I have doubled my data. Here I have a post operator plus plus where I have divided the data by 3, anything I can do. That is up to me as to what I want. So, when I do that, it becomes a map to that particular operation, but it is usually a good design practice that you keep the semantics of the object or semantics of the type as close to the built-in type as possible. So, if I have a pre-increment operator which actually makes it double for a complex, then it probably is not something which is very good. Right. For example, if for a rational, if I want to do a pre-increment, that would mean that I add 1 to that fraction and return that value. If I do a post increment, it will mean that I return that value and then add 1 to that function and so on and so forth, right. But it is possible, I mean programming wise it is possible to do this, design wise you may be more choosy as to, because you know what will happen is if I do this for a say my complex type, I have complex C and then I write plus plus C, anybody who reads the code would instinctively think that this is incrementing the complex number, but you are actually maybe doubling the components or doing something. So, though you are building up an algebra, that algebra deviates from the normal semantics that most of us understand. So, that deviation makes the program much less readable and confusing and potential for error. So, these are, but this is design choice. I am telling you again, programming wise you can write anything that you want to write in terms of these unary operators. So, that brings us to the end of the first part of operator overloading, where we have seen how I can overload operators, recapitulating on what we did on module 9 and module 14, and noted that I can do it as a global function and I can do it as a member function as well. We will going forward in the next module, we will see how we can make use of the friend function and how we can do some very useful overloading, particularly for the input output operator. Thank you very much for your attention. See you in the next module.